Hello everyone, in this video I am going to talk about logistic regression and how to implement it using Python. In the end of this video, I will show experimental result on the Reddit scoring problem. In many real-world datasets, the data is not linear separable. The linear regression cannot fit in the data. When on the right side, when we see a logistic regression on the right side, right chart, we have a better intuition that it will fit the data shape. The other reason use logistic regression is because it's the having categorical outcome variable violate the assumption of linearity of normal regression. We can see the weight is not linear with the height. And the other reason for use logistic regression because it doesn't assume linear relationship between predictor variable and the independent variable. That's not a case of linear regression. Logistic regression will combine this independent variable to predict probability of event occur. The output of logistic regression is in range 0 and 1. And logistic regression can be used for classification by choosing a threshold. Suppose we have the dataset with d dimension. We can icon it the sample is phi and the label it belong to class 0 or 1, and we define the linear combination quality which is sum across the dimension of sample, and we call the parameter e theta, and the logistic sigma function will take the logistic regression will take the sigmoid of a model. The SA will equal to 1 the divide to 1 as e trừ a trừ a, and we can see here is the S-sharp curve of the sigma function. When this is threshold is 0.5. When a is greater than 0, we will assign SA to 1. That's 1. And when a is very little than 0, it will assign SA to 0. We can see in this slide the conditional probability of the label 1 on the sample phi is equal to SA, and we can replace A by the combination of theta and phi. So when the theta multiplied by phi is greater than 0, so the probability of y equal to 1. Approximate 1, so we classify the sample to plus 1. and otherwise we will classify the sample to last zero. This is last zero error. This is last one error, and the cost function is sum of last one error and last zero error. So we supposed to find the theta to minimize the cost function c theta, which means we can which means we will find the best model for fitting data. So to find the theta minimize the c of theta, we need to calculate the radiance of the c theta with respect to theta. The radiance is this is this equation. First, we need to calculate the radiance of s respect to a. Is equal to sa multiplied with 1 subtract to sa. Then we will calculate s respect to theta, which equal to phi p multiplied with 1 to p. Then we will use the gradient descent method for find the better theta, and this algorithm will introduce the alpha, which is the learning rate. Usually is equal to 0.01, and this algorithm will repeat the update theta to find the minimum of c theta. To find the theta which at this point the c theta is minimum. To implement a logistic regression, we use the NumPy to generate the random parameter and define the class logistic regression, which the separate methods fit for training on the dataset reduce and reduce class accordingly to the reduce the probability and the reduce class sample. The gradient method for red gradient of current loss function respect to current value of parameter, and loss method for calculate current loss. This is the method for red gradient. Define the separate method for sigmoid function and use the convenient function from NumPy to calculate dot product between the dataset X and the parameter beta. Also, we define the fixed intercept to strict between the model use intercept or not. The training method is used for loop to iterate find the new parameter updates better than the previous one. This is the k epoch. This is the k log 1 epoch. After implement the logistic regression on using Python, I will try this model on the release current program. This is the data. This is the main is column for describe the user information. First, we can see here the car is in this indicate whether the user has the card. The age value, there are um, some column which need to be uh, care about. First, age. This is the plot number. It means the end year plus 12 year. Uh, how long about user has card. The yearly income uh, in uh, it will be divided by 10,000 USD. The and other major card it means uh, a user has major uh, number of card the user have and major credit card user have. For training this model, first I use some precision mechanism. The categorical variable card owner sum is encode will yes and no to value 1 and 0. The data will be normalized to range 0 and 1. The dataset will split into transit and dataset with ratio 0.a and 0.2. Model will be optimized using gradient descent algorithm with 10,000 iterations, and learning rate is 0.01. This is the learning curve of the training process. We can see the accuracy will incremental per epoch, and it will all go over 0 dot 9 after about 500 epoch, and the cost function will decrease, and it will be converged after 5,000 epochs. I also compare the model performance with the scikit-learn library, and I achieved the same accuracy with it with a 94% accuracy on test set. Thank you so much for listening this presentation, and hope to see you in the next topic.